In this lesson, we're going to take a closer look at polynomials and their zeros. And we're going to start with something called the fundamental theorem of algebra, which is exactly as important as it sounds, but it's also not that complicated. The fundamental theorem is that every equation, every polynomial, has at least one complex root. Could be real, could be imaginary, but there has to be some number that makes that equation equal to zero. And an extension of this, and this is the part that's important to us, is that every polynomial with a degree of n has n roots. Again, some of them could be real, some of them could be imaginary. But what that means is a fifth degree polynomial, so x to the fifth, has to have 5 roots. A 17th degree polynomial, x to the 17th, has to have 17 roots. So you always know exactly how many answers you need to find just by looking at the polynomial. That's a big deal. So if you're given a cubic polynomial, you know you need to find 3 zeros. And so what we're going to talk about today is how to find those zeros. So let's say you need to find all the zeros of f of x equals x cubed minus 4x squared plus 6x minus 4. The first thing you say to yourself is, how many zeros will there be? Since it is a cubic function, there will have to be 3 zeros. And we're going to find them all. Some of them might be real, some of them might be imaginary. And so step 1, we're going to use the same connection we made last class. We talked about the graph of the function. We can find a zero by looking at the graph. Next class, we'll talk about what to do if you aren't allowed to graph or don't have a grapher in front of you. But we'll start by looking at the graph. And here's the graph of x cubed minus 4x squared plus 6x minus 4. You can check it on Desmos on your own. And just by looking at the graph and verifying it in Desmos, we can see that 2 is an x-intercept. There's an x-intercept at x equals 2, which means f of 2 equals 0, which means x equals 2 is a 0. And one step farther we can go is one of the factors of that polynomial is x minus 2. Okay, but we said there were going to be 3 zeros, and I only see 1. So how are we going to find the other 2? If you can't see them, that means they must be imaginary. It's possible that, the graph turns around and like that, but this one doesn't. We're already at the end behavior here. So where are the other zeros? Well, they must be imaginary. Our job is to find them. So that's the next step here. And this is similar to what we did last class with factors. What we're going to do is take out the factor that we found, or take out the zero that we found, to leave us with a quadratic that we can solve to find the rest. So if we know that 2 is a 0 and x minus 2 is a factor, we can take our x cubed minus 4x squared plus 6x minus 4 and divide it by x minus 2 using synthetic division. And that's what we'll do. Bring down my 1, 2 times 1, negative 4 plus 2. 2 times negative 2, 6 minus 4. 2 times 2. And this has to be 0. If we don't end with a 0, something is horribly wrong. We know there has to be a 0 there because we already said that x minus 2 is a factor of the polynomial. So we know x minus 2 has to go into the original cubic evenly, which means the remainder has to be 0. And then what we're left with here, this 1, negative 2, 2, that is x squared minus 2x plus 2. Which tells us that our original cubic polynomial can be factored to x minus 2 times x squared minus 2x plus 2. We've now discovered that. Unfortunately, x squared minus 2x plus 2 doesn't factor. There's nothing that multiplies to 2 and adds to negative 2. If we wanted to take a look at that parabola, there would be no x-intercepts. So we need to find the roots some other way. This is why it didn't show up on the graph, because they're imaginary. Well, we know how to find roots. What we're looking for, and this is like you got to make the connection between finding the roots or finding the zeros and saying that means we are solving the equation. We want to find out when does this quadratic equal 0? Well, we have the resources for this. We're going to find the zeros of that quadratic equation. So I'm going to take x squared minus 2x plus 2 equals 0, and I'm going to solve that. This one doesn't factor, but I can complete the square pretty easily. I need to add 1 to both sides to make that work. When we take the square root of that -1, we get just plain old I. Of course, it's plus or minus. And so x equals 1 plus or minus I, which are our other two roots. Of course, remember that we had another root from before, so I don't want to forget about that. So my solutions are x equals 2, which we found from the graph, and 1 plus or minus I, which we found from solving the quadratic. And that would be the answer to the question.